Seema, and welcome to part 2 of the chapter Redox Reactions. I told you the different definitions of oxidation and reduction. And in the different definitions, we came to the fifth definition, which said that redox reactions can be explained in terms of electron transfer. So the topic of this video is redox reactions in terms of electron transfer. I told you when I discussed in part 1 that any substance that loses electrons is said to be oxidized and anything that gains electrons is said to be reduced. So we'll understand this taking some examples. Let us take this example of sodium and chlorine reacting with each other to give you sodium chloride. When sodium and chlorine react with each other to give you sodium chloride, we are aware that sodium chloride is an ionic compound. So in sodium chloride, sodium has a positive charge and chloride ion, that is chlorine, has a negative charge forming the chloride ion. So if you have two sodiums, each sodium atom loses one electron each, so there's a loss of two electrons, and only when the atom loses electrons does it acquire a positive charge. So you get two sodium ions which are positively charged by the loss of two electrons, so each sodium atom loses an electron. And loss of electrons is oxidation. At the same time, whatever these two electrons were lost, who gains these electrons? We know chlorine in chlorine molecule has a charge of 0. It gains one electron to become negatively charged. So the electron, let us take one sodium and one chlorine. The electron that sodium lost, chlorine atom gains that one electron and becomes chloride ion. So that electron that sodium loses, chlorine atom gains that electron and becomes a chloride ion. In order to balance the equation, since chlorine molecule is Cl2, therefore we have to take these two sodium ions, will give the two electrons, and both the chlorine atoms will gain one electron each and form two chloride ions, and therefore you will get two formula units of sodium chloride. So if chlorine gains electrons, it means that chlorine is getting reduced. So this is nothing but a redox reaction, only you explain the redox reaction in terms of the transfer of electrons from sodium to chlorine. Remember, sodium will not lose its electron unless and until it has another atom to receive it. You have a lot of food and a lot of spare food also. You don't really need all of it, but you've been taught that you should not be wasting food. So what will you do? You'll try to save that food in a fridge and you'll try to preserve it because you've been told that you should not be wasting the food. But a beggar comes by and that beggar needs the food. What would you do? You would give the food to the beggar. So that food is not wasted, you've given it to another person who was in need of it. So these metallic atoms which lose electrons, they cannot lose electrons unless and until there is a beggar around, and that beggar is the non-metallic atom or the atom that receives the electron. Right? So in this case it is the metal and non-metal. We'll come to displacement reactions where both of them will be metals. So an atom can lose electrons only if it has another atom who is ready to accept that electron. So sodium will only get oxidized if there is another atom present who is ready to get reduced. So in order to oxidize sodium, chlorine had to get reduced. And in order for chlorine to get reduced, sodium had to get oxidized. So oxidation and reduction can never occur alone. They always occur together. If one substance is getting oxidized, the other substance is oxidizing it, and it itself, to do that, it itself is getting reduced. And if one substance is getting reduced, the other substance is getting oxidized in order to make it reduced. So it is a dependent relationship. So on the basis of this, chlorine got reduced, but who reduced chlorine? Sodium reduced chlorine. But what happened to sodium? Sodium got oxidized. So sodium itself got oxidized, but it acted as the reducing agent for chlorine. It reduced chlorine. So who was the cause of the reduction of chlorine? Sodium. So sodium is the reducing agent. Any substance that itself gets oxidized acts as the reducing agent, and any substance that itself gets reduced acts as the oxidizing agent. So chlorine itself got reduced, but it oxidized sodium. Therefore, chlorine is reduced, but it is the oxidizing agent. Sodium is oxidized and it is the reducing agent. Let us take two more examples now. Sodium combines with oxygen to give you sodium oxide. In sodium oxide, oxygen has 2 negative charge and sodium has 1 positive charge. So you need 2 sodium atoms to give 2 electrons, and these 2 electrons are gained by oxygen to give you this should be 4Na and this should be, the equation is not balanced. So let me just correct this. You will need 4 sodiums to balance the number of electrons, which would lose 4 electrons, and the 2 atoms of oxygen will gain 4 electrons, and you'll get 2 moles of Na2O. Now the number of electrons would be balanced. 4 electrons and 4 electrons. Loss of loses 4 electrons, gains 4 electrons, right? So sodium, 4 sodiums lose 4 electrons. That is, each sodium loses 1 electron, and loss of electrons is oxidation. And oxygen, each oxygen atom gains 2 electrons, and there are 2 oxygen atoms, so 4 electrons, so, resulting in the formation of Na2 positive, O2 negative, 2 moles of it. So sodium got oxidized while oxygen got reduced. Sodium is the reducing agent and oxygen is the oxidizing agent. Again, you have sodium combining with sulfur to form sodium sulfide. Sodium loses 2 electrons, sulfur gains 2 electrons. So sodium, 2 atoms of sodium, each one loses 1 electron each, so loss of 2 electrons total. So we'll give you Na positive ion, so Na2S, and the charge on sulfur is 2 negative. So sodium got oxidized, sulfur got reduced. Sodium is the reducing agent and sulfur is the oxidizing agent. So these are some basic concepts and terms that you should be aware of. What is getting oxidized? How do you define it in terms of electron transfer? How do you define a substance getting reduced in terms of electron transfer? And what is an oxidizing agent and what is a reducing agent? Having understood this redox reaction can be understood as 2 processes. I told you there are 2 processes which are taking place simultaneously: oxidation and reduction. So this reaction, each reaction, redox reaction, can be divided into 2 halves, and these halves are known as the half reactions. So if you take this example of sodium chloride, let us write only the reaction of sodium. Sodium atom loses 2 electrons. So we write sodium atom gives you sodium ions and it loses 2 electrons. So it produces, sodium atom breaks 2 electrons break to form Na positive, 2 Na positive, and 2 electrons are given out. On the other hand, what happens to chlorine? Chlorine gains 2 electrons which are given out by sodium, and it results in the formation of chloride ions. And the overall redox reaction is the sum of the 2 half reactions. If you have to write down the sum of 2 half reactions, how do you do it? You always cancel out the things which are present on the reactant side and on the product side also. Those will get cancelled. Rest of the species will be written in the overall reaction. So you have sodium in the reactant and it is not there in the products. Do you see? You have Na positive. You have Cl2, but you do not have Cl2 in the products. You have Cl negative. But you have 2 electrons in the reactants which are also there in the products. So this ingredient will get cancelled out. When this gets cancelled out, now what are you left with in the reactants in the products? You're left with 2Na, you're left with chlorine, you're left with 2Na positive, and you're left with 2Cl negative. That forms the overall reaction. So you'll write down the overall reaction would be 2Na plus Cl2 from here will give you 2Na positive and Cl negative, which is nothing but twice NaCl. So here you also understood one more thing, that we report these reactions as half reactions, and the overall redox reaction is the sum of the 2 half reactions. There is a question in your textbook that says that 2Na plus H2 gives you 2NaH, And the question is, you have to justify that this is a redox reaction. Is it a redox reaction? If yes, then justify. Yes, it is a redox reaction. Why? Because sodium hydride is an ionic compound. It means in this sodium hydride, Na is positive and H is negative. Na has one positive charge and H has one negative charge. So since you have H2, you need two sodiums. Every hydrogen needs one electron. So sodium gives only one electron. So there should be two sodiums to give you the two electrons. So two sodium atoms lose two electrons and the two hydrogen atoms gain two electrons to give you the ionic compound NaH. You can explain this by writing down the half reactions of this. And how would you write down the half reactions? If I take this, just the oxidation, we'll write that 2Na will give you 2Na positive plus 2 electrons, and hydrogen H2 plus 2 electrons will give you 2H negative, right? And then the overall reaction, what will it be? It would be the H2 Na will remain, the 2 electrons will get cancelled, and the overall reaction would be this, that 2Na plus H2 will give you 2NaH. So that is how you could write the overall reaction here. So having understood this, we've just understood that you can write, you can define reactions as redox reactions in terms of electrons. Then we understood that what is the substance, how do you define oxidation, how do you define reduction, what is an oxidizing agent, what is a reducing agent, how we can write two half reactions, and how the sum of these half reactions forms the overall reaction. Having understood this, now we need to know just one more thing. When you have here in all these examples, we had an electropositive atom and an electronegative atom, that is a metal and a non-metal. If you have species, you may have species where you have two metals, and electron transfers from one metal to the other metal. So one of the metals is getting oxidized and the other metal present in another compound may be getting reduced. And this also happens. So such a transfer is seen, and we have noticed that there is a competition in such a case. Let us understand what this competition is with the help of examples. You have copper nitrate solution, which is blue in color, and you put a zinc strip in it, a rod of zinc or some scraped zinc into this. We notice that over time, the blue color of the solution, which was of copper nitrate, it starts getting lighter and lighter until all of it turns colorless. So copper salts give you blue color when you have copper ions present in them, that is Cu2 positive is present in them. And the colorless solution is usually of a zinc salt. So it means that zinc, it is a displacement reaction. Zinc took the place of copper and formed zinc nitrate, and copper was given out. Now what you have to pay attention on is the nitrate ion has a negative charge and the copper ion has a 2 positive charge. Zinc metal has a 0 charge. So what is happening to the charges? If we looked at, we'll be able to define it in terms of a redox reaction. In zinc nitrate, the moment zinc forms a salt, zinc is present as an ion. So zinc is present as 2 positive. Nitrate, of course, is a negative charged ion. And copper solid metal has a 0 charge. What has happened to the charges here? Notice, zinc had 0 charge. It became 2 positive. How can zinc turn into Zn2 positive? By losing 2 electrons. So zinc lost 2 electrons, but then who gained those 2 electrons? Nitrate was negatively charged, nitrate is negatively charged, nothing, there was no change in the nitrate ion. But copper ion was Cu2 positive. It turned into copper 0. It means it gained 2 electrons. It had 2 positive charges, and the 2 positive charges can only be cancelled by gaining 2 negative charges. So it gained 2 electrons and it resulted in the formation of copper metal. So we see this is not only a displacement reaction, it is also a redox reaction in which zinc lost electrons, therefore zinc got oxidized and copper ions got reduced. So zinc is the reducing agent while copper ions are the oxidizing agent. So if we ignore the ion that did not change, that is the nitrate ion, we can see that the actual redox occurred between the two metallic atoms, that is zinc and copper ion. Both of them are electropositive. Both of them have a tendency to lose electrons. If you see in their compounds, both of them had 2 positive charge. So both of them have a tendency to lose electrons, but it was zinc who took the place of copper. Now the color has been lost. We have got a zinc nitrate solution. So let us try the opposite. This copper, which is already present, we take another copper rod and we dip it into this solution to check what is going to happen. When we put a copper rod, and of course this copper is also present, which is not reacting for some reason, and we think that there may be some reason that it has been pushed out, so it is angry, it's not reacting. So we put fresh copper we dip a fresh copper rod into the solution, and we want to see what? That zinc took the place of copper. Can copper take the place of zinc in zinc nitrate? The reaction does not occur. You do not get, from the colorless solution of zinc nitrate, you do not get a solution of copper nitrate which is blue in color. It remains colorless and nothing happens to the copper rod, no reaction takes place. Interesting? What does this show? Whoever is more powerful gets to lose the electrons. Whoever is the bigger king, I am the mightier king can donate. The weaker king has to accept it from the mightier king. So, zinc has a stronger tendency to lose electrons than copper. This is what we understand from this. That when we tried to put copper in a zinc nitrate solution, copper could not lose electrons to zinc, but zinc can lose electrons to copper. Then, now for example, where I come to that you having food and the beggar. So instead of you, let us imagine a king. So the king can donate to the beggar. But have you seen the beggar donating to the king? The king is too proud to accept any donations. So zinc is too proud to accept electrons from the beggar copper. So which means copper is weaker and zinc is a stronger, it has a stronger tendency to get oxidized, or it is a stronger reducing agent in comparison to copper. So if you pass H2S through zinc ions, any solution of containing zinc ions, you get a white precipitate of zinc sulfide. And in this one, the blue color disappeared, and then we bubbled H2S gas through it to check if the zinc has got converted into Zn2 positive. And yes, we got the white color of zinc sulfide, which shows that the zinc metal is now present as Zn2 positive ions. And in order to test the equilibrium, if we put a copper strip, I just explained this to you, that if we put the copper strip into the zinc sulfate solution, reaction does not occur because copper cannot displace zinc. Zinc can displace copper from its salt solution. We take another example. Copper reacts with a silver solution, a solution of a silver salt. Silver salts are usually colorless in nature, but copper salts are blue in color. So we notice that when you make copper, when you dip a copper rod in a silver nitrate solution or any solution of silver ions, now copper can displace silver. So when copper displaces silver, you will get, how would it displace silver? By losing 2 electrons. So copper gets oxidized, it becomes Cu2 positive, so copper is oxidized. Silver and Ag positive gains 1 electron. So 2 silver atoms gain the 2 electrons, it gets reduced and you get silver, metallic silver. But the copper salt that is formed, the solution which was colorless, now becomes blue. So what does this tell us? That if zinc was the king and copper was the weaker person there, in comparison to silver, it is copper which is stronger. So copper, the reactivity or the tendency to lose electrons of copper falls between zinc and silver, right? So, and here in terms of oxidation and reduction, copper got oxidized, silver ion got reduced. This is the reducing agent, this is the oxidizing agent. Another example, you take cobalt and you make it react with a nickel salt. We get cobalt ions and we get nickel. This displacement occurs, but an equilibrium gets established. And when you check the concentrations of the reactants and the products in the state of equilibrium, we find that all the reactants and the products, all of them have almost the same concentration, which means that copper cobalt and nickel, such a displacement occurs, but the difference between the two is not so high. The difference of what? The difference between the strength to lose electrons is not so much. Therefore, not all ions are displaced. Some are, and the reverse reaction can also take place, because when you are two people are fighting and both of them have almost an equal strength. If you have one person who's really strong and the other is very weak, slam dunk, he just gives him one hit and he falls down to the ground. But if you have two who are of equal strength, that is when the fight is almost equal and it goes longer. This pushes him, he pushes him, he pushes him, he pushes him, and both of them stay in the game. It's the same with cobalt and nickel. Their strength or their ability to lose electrons is almost very, very close, and therefore they establish an equilibrium. So what does this tell us about the different metals and about their strength, that this can displace him and he can displace him? It shows that we can make a series, we can make a sequence of metals based on the strength with which they will lose electrons, or how easy it is for them to lose electrons. And this series that has been made is known, of the metals, is known as the activity series or the electrochemical series. And if you remember, in lower classes, I think students are made to memorize the electrochemical series. And it is Kaba Kana, Mag al-Zankar, Fikadko, Nisanpab, Haku, Hag. Oh, right? Potassium, barium, calcium, sodium, magnesium, aluminum, zinc, chromium, iron, cadmium, cobalt, nickel, tin, lead, hydrogen. Hydrogen is the only non-metal which is present in the electrochemical series. Then comes copper, mercury, silver, gold, and platinum. So this is the series or the activity series of metals. And you see zinc, copper, silver. Where are zinc, copper, and silver? Silver is here, copper is here, and zinc is here. Now do you understand? According to their tendency, which has the strongest tendency to lose electrons is on top, and the one which has least tendency to lose electrons is at the bottom. So zinc is stronger, it can displace copper, and copper can displace silver. So metals which are lower in the series, they can be displaced by metals higher up in the series. But metals which are lower in the series cannot displace a metal which is higher up in the series. So to know which metal is going to reduce the other one, you must know the metal activity series, right? Its capacity to reduce the other metal would be known by its capacity to get oxidized itself. So that is the metal activity series. And where do we use this knowledge? When we make galvanic cells, you will be studying electrochemistry in class 12. When we make galvanic cells, we choose electrodes and solutions which are of metals which have a large difference between their reducing properties. And when that happens, a potential gradient is created, and that potential is known as the EMF of the cell. The difference between the potentials of the two electrodes will generate electric current. So this knowledge helps us to prepare galvanic cells. You will study this in class 12. So it helps to memorize the activity series. It may not be very, very accurate, but predominantly it is. It is Kaba Kana, Mag al-Zankar, Fikadko, Nisanpab, Haku Ag, Hag Ag, or Pat. Hydrogen is the only non-metal in it because hydrogen is the only non-metal which is really so electropositive in nature. So it can be placed along with the metals. That is the reason why hydrogen has been kept separate in the periodic table also. It is because it has similarities to metals. So with this, I'll finish the topic. If you found the video helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.